Since John is not here, I'm going to be doing the opening prayer. And then after the opening prayer, I will be doing a little bit of the house cleaning to kind of do what I normally do. And after that, Terry will introduce our guests. And then our guests can go on and continue what they love to do and talk about our lovely solar system. So, as we begin our prayer, if everyone, if won't mind, just closing your eyes and taking a deep breath as I read this prayer. Loving Creator, we give thanks for this new morning and for the wonders of the universe that reflect your majesty. Bless Susan and Bill as they guide us through the stars and skies. May this time spark curiosity, joy, and a deeper awe for the beauty of your creation. Amen.
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 How did you get the word on?
Uh,
We never hear that at our church.
you know, I'm gonna be honest, I didn't write it.
Okay.
Well, let's be clear. So for the housekeeping, as Bill and Susan are going through their presentation, they'll be showing slides. Um, if you could keep your mics muted throughout their time of presentation, that would be greatly appreciated. There are going to be, if you have any questions, we have suggested that you write down the name, the number of slide. It'll be on the bottom right corner of each slide. You'll see the number, and then write your question in the chat box. So just write the slide number that you have a question about, then your question, and then at the end of the presentation, Bill and Susan will read off the questions in the chat, and if there are more after the fact, we can continue with the Q&A as we see fit. And so with that further ado, Terry, take it away.
Okay, well, welcome everybody. It's nice to see you. I'm Terry Morrison, and it's my honor to introduce our two guests today. Susan and Bill O'Neill joined LAUMC in 1998. They were looking for a church that had a wonderful youth program for their daughter, Shannon, and LAUMC was the perfect fit. While they were at LAUMC, they were in all the various choirs, and Susan did so much volunteer work, a lot with Bonnie Bullwinkle in terms of raising money for the Alzheimer's Association. She served on many committees, the nominations committee, the worship arts committee, board of trustees, and she planned so many of the women's church retreats and is the best organizer and person ever. So we are so blessed to have had her there at LAUMC. Bill retired in 2008, and he returned to his childhood interest in astronomy. He took courses in astronomy. He bought a telescope. He joined the San Jose Astronomical Society, and it's just been a huge passion of his ever since. In the summer of 2013, the two of them volunteered to lead astronomy outreach at Glacier National Park. They manned the solar telescope during the day, then they took a break for dinner, and then at night they set up stargazing. And during the month of August, when they were there, they talked with more than 4,500 park visitors. So those park visitors were really lucky. In 2018,
Susan did all the heavy lifting on that.
In 2018, they moved to Seattle to be closer to their daughter, Shannon, and her family. And Susan and Bill are the proud grandparents of two boys, ages 2 and 6, and feel so blessed that they get to babysit the boys. Stephen, who is Shannon's husband, teaches music at the Institute of Technology, and he's also the choir director at the First Congregational Church in Bellevue. Susan and Bill joined that church, and Susan is in the choir. As Susan just said, it's a much smaller church, but they just have a wonderful sense of community. So they're really happy to be there. Bill has joined the Seattle Astronomical Association, and he sets up monthly star parties. But up there in Washington, it gets cloudy and rainy and so forth
Sketchy.
and so on.
It
And
is
so,
sketchy.
unfortunately, they have to cancel a lot of those parties, but they're set up for the public. So they do, again, so much good service. So they're really happy to share their interest and passion in astronomy today, and we are thrilled to have them. So without further ado, we wish to welcome Susan and Bill O'Neill. Thank you.
Greetings and salutations. Yeah, it is sketchy up here weather-wise, and we both lived in Sunnyvale, California for 30 years. Sunnyvale, right? We moved up to Seattle, so we're paying the price. Okay, Kyle, what do we do next? Do I click on share or what?
Yeah, you're gonna hit the share button on the bottom, and then you're gonna find the PowerPoint. And
All
you
right.
only want to
So
share the PowerPoint screen.
the one down here at Microsoft. Okay. Okay, so we got the gallery over here on the right, and we're ready to go. All right, let's sort of see what goes on here. So this is my retired business card. So Susan and I retired. She worked at Apple, and I was in the Silicon Valley thing for a long time. And when we packed it in, we decided we would volunteer for the National Park Service because they're always looking for volunteers, and we figured it would be fun to work at a national park. And so we put our name in, and the joke is we thought we'd get Death Valley in the summer, some armpit of the Park Service, and fortunately, they called and said, "Would you like to work at Glacier National Park?" Which is a fantastic place to go, and we had never been there, so we said, "Yeah, sign us up," and we jumped in the car and went up there one summer. And we spent, I think, June, July, August, and part of September. They have to close in middle of September because the Going to the Sun Road gets snowed in. So I mean, it's a real high elevation, lots of glaciers, lots of things, but a lot of visitors. So it was a great thing to work on. All right, here we are in our ranger outfits. Ooh, got the official cap and the, the uh, pants and shirts and pants and stuff like that. But here's the question for you. These guys, we're in front of Lake McDonald, so we're on the west side of the park, and we've got two telescopes, but we're in the daytime. So what are we thinking? What's going on? What's this all about? So I'll have Susan and I will swap seats here, and I'll have her tell you a little bit about solar astronomy. All right.
Yeah, for some reason, we can't get both of us
In the same
in
picture.
the same picture, so we're swapping to make it easier for you guys.
So you're up in here, and I was on.
Okay, now you can see me. Okay, hi everybody. It was so great to see many of you this past weekend. I was glad Shannon and I could come down to Dirk and Carol's celebration. And didn't get to spend a whole lot of time with everyone, but got to see a lot of people, got a lot of hugs and brief catch-ups. It was great. Wouldn't have missed it for the world. But I'm also going to say, please bear with me because I wrote a lot of notes on what I want to tell you. So I'm going to be looking some of the time at my notes and not at the camera, so not at you guys. So anyways, bear with me. Okay, next picture. This is what the images look like on the two telescopes in the previous picture. And as the telescope on the right is a special hydrogen alpha telescope dedicated to looking at the sun only. Hydrogen alpha is a special wavelength of red sunlight that's generated by hydrogen. The sun is made up of mostly hydrogen, and so that's why we like to look at it at this particular wavelength. We can see prominences leaping off the surface of the sun. The prominence at the bottom right here is probably 2 Earth diameters. The left telescope used a strong mylar filter to block 99.999999% of the light. This is a filter that can be attached to a regular star viewing telescope to safely view the sun. You'll see sunspots on both, and they were taken on basically the same day. So you see it here and there and up here and there. And because it's at a different spot on the sun, it looks different. It's adding to it each image. Now, just a reminder that remember what your mom told you. Never look directly at the sun. You could go blind, and people have. You don't want to do that. Always use special solar glasses or use a solar filter. Regular sunglasses are not good enough. Okay, this spectacular photo of our sun was taken using a hydrogen alpha telescope on February 22nd, 2023 by Mehmet Ergan from Germany. It was awarded the NASA Astronomical Photo of the Day, and it's just kind of spectacular. The core of the sun is very hot, millions of degrees. The core is so dense that a quart of material from the core would weigh more than a person. That density and pressure is what causes the sun to generate energy by fusing hydrogen into helium. Who has ever cooked spaghetti? Let's think of the sun like a boiling pot of water and spaghetti. The bottom of the pot is the core of the sun. The spaghetti is moving all around in the boiling water. Occasionally, a strand of spaghetti pops through the surface. Sometimes the magnetic field lines pop through the surface of the sun to make a
Hi,
sunspot.
sorry to interrupt. Your presentation went away.
Oh,
Let's see. It looks good on my screen here.
What's going on?
Ba-bum. Just sort of see here where we're at.
we're on Zoom.
And we're on Zoom.
And you just go to
Is that any better?
no, can you click Zoom on the bottom?
Where's the Zoom on the bottom?
It's a blue icon on the bottom of your screen.
No, it's not.
We don't see the
Let me go back up.
choices.
Do you see this?
Oh, no, hold on. I know what's going on here. Someone else is sharing. There we go.
Okay.
So, yeah.
That one.
So now,
Yeah, you're good.
All right.
Okay.
Thank you.
all right. Okay, let me figure out where I was.
Sorry about that.
No, there's no problem. Another phenomena closely tied to sunspots and magnetic activity in the sun is coronal mass ejections, or CMEs. These massive bursts of solar wind and magnetic fields erupt outward from the sun's corona and often accompany solar flares. When these ejections are directed towards Earth, they can lead to geomagnetic storms, resulting in breathtaking auroras as charged particles collide with the Earth's atmosphere. However, the beauty of these events belies the potential for disruption they can cause to modern technology, as scientists and historians have documented over time. The largest recorded CME occurred on September 3rd, 1859. In New York, it was reported one could read a newspaper by the light of the aurora. There was no GPS, no phones, very, very few electric lights. They were just experimenting with electricity, so there wasn't much around. People sent messages via telegraph machines that were connected by wires and worked by tapping out Morse code. That night, telegraph systems all over North America and Europe stopped working. Some operators even received electric shocks, and the paper they were printing on caught fire. Richard Carrington, a British astronomer, saw a huge bright flash on the sun the day before. He wasn't sure what he was seeing. Turns out this was the first time anyone had observed a solar flare. Scientists started putting all these pieces together and for the first time realized that changes in the sun could have dramatic consequences here on Earth. This became known as the Carrington event. You've seen rainbows, and a rainbow comes from a prism. In this case, the water in the raindrops is refracting the white light into its colors. All the colors of the rainbow make up the color white. This is a diagram of a glass prism. See how the longer wavelengths of red are not refracted very far, but the shorter wavelengths of blue and violet are bent much further. And this is a spectrum of all visible light. The dark emission lines show the chemical elements, and you notice hydrogen alpha is 600 at 656.28 nanometers. This is a poster by NASA that's distributed to people who want to talk about the sun. The 3 images of the sun were taken on the same day, March 6th, 2011, using different kinds of camera filters. They allow us to explore more than we can see simply with our eyes. These features are all caused by the dynamic magnetic energy of the sun. If the sun did not have changing magnetic activity, it would be a plain, uninteresting, boring face. To put the size of the sun in perspective, the little dot in this blue box, like that little dot, shows how big the Earth is compared to the size of the sun. About as big as some of these sunspots we see on the sun.
I point out the flare on the hydrogen alpha one too on the left-hand side.
Yeah, I haven't gotten there.
Okay.
Okay. The yellow image is the photosphere. You can see the sunspots, which mark where the twisted magnetic field lines pour through the surface of the sun, like our spaghetti imagery I mentioned before. The middle image is what we would have seen that day in a hydrogen alpha telescope. This layer, called the chromosphere, is just above the photosphere. Around the edge, you see prominences lifted out of the sun's surface by the magnetic activity. And as Bill was trying to get me to show you earlier, here's one. And that's probably at least 3 or 4 diameters of the Earth. Here's another one up here and up here. But yet here's the same sunspot area that we saw on this one. So we see them, the same spots, but they look different because they're at a different level and a different wavelength. Let's see, the right image was taken with an ultraviolet or UV filter. The bright areas that look like clouds above the sunspots are really hot and are generated from material heated by the strong magnetic fields. This image is actually from a UV detecting telescope out in space. We wouldn't see that same image if we took it on Earth the way we did with this image and that image. The lower image shows the outer atmosphere of the sun, the corona. All these particles are streaming out from the sun. They're very hot and generated from material. Oh no, that's wrong. Sorry. All these particles streaming away from the sun all the time, but we only see them during a total eclipse of the sun. So Bill and I were in Mazatlan last year for the solar eclipse, and we actually saw this kind of activity and showed up on some of our photos. Bill's going to talk to you now about the solar system.
Okay, next. Thank you. All right. All right, I am back. So let's go to our stuff. So way over here on the left is the sun, and Susan was just talking about. It's hot, hot, hot. That's why it keeps us warm and alive and healthy and all this good stuff. We wouldn't have life on Earth without the sun, so don't knock it. It's going to be around for another 5 billion years. So us retired folks don't have anything to worry about, So, there's a joke about a college professor was lecturing about the sun, and he said it's going to be around 5 billion years. One of the students jumped up and said, "What did you say? What did you say?" He said, "It'll be around for 5 billion years." And the student says, "Oh, whew, I thought you said 5 million years." Anyway, moving right along. So let's see what we got here. So, do you know the names of all your favorite planets? I even included Pluto, because I know we're all old enough to know how that went. But anyway, Mercury, Venus, Earth, and then the gas giants, Jupiter, Saturn, Uranus, and Neptune, and Pluto. So one of the things we use to teach is a mnemonic, which is just a sentence or a phrase that helps you remember the order of things by putting a word with the same starting letter into a sentence. So for example, for the Mercury, Venus, and Earth, we use my very educated mother for MVEM. And then for the second half of the sentence, it was just sent us 9 pizzas. But nowadays, because Pluto's a dwarf planet, their pizzas is lowercase. So we understand that. All right, you got it. All right, here's the sort of a bird's eye view of our solar system. The sun is in dead center. Let me grab the mouse here. Yeah, sun is dead center. And the first one out is Mercury, and then next comes Venus. Then Earth is the third rock from the sun. You all remember that. And then further out is Mars and Jupiter, and way out here is Saturn, and then way out is Uranus and Neptune and Pluto. So what I wanted to show you is we didn't talk about this, Kyle, and I hadn't thought much about it. Let's try this. So here's the image of, a top-down image of a solar system, right? The sun's in the middle, and then all of the planets have a nice circular orbit around it. And they are pretty circular, so it doesn't change very much. But what's important to understand is that if you start to look at it on an edge, all right, eventually they're all going to turn into basically what's a line. I can't quite get it there on the screen, but it's a line that when we look at it from Earth, all the planets and the sun and the Earth follow along that line from our vantage point, from our point of view. And it's high up in the sky, and it goes from so that the sun rises in the east and sets in the west. Well, so does the moon, and so does Mercury and Venus and all the other planets. So now you know how that works. All right, talk about how do we know where we are, and the guiding star is the North Star. It's called Polaris, and it's pretty easy to find for us Northerners. You find the Big Dipper, which is Ursa Major, the constellation Ursa Major, but they use the phrase an asterism, which is just a pattern of stars that you can recognize. So here's the Big Dipper, here's the dipper part, here's the handle, all that good stuff. And what you do is you take the distance between Merak and Dubhe, the front 2 stars, and you make that go 5 times out. You follow up that path. So you go 1, 2, 3, 4, 5, and you come to Polaris. And so that's how you can tell where Polaris is. And that's the tail of the Little Dipper when you look at the total north sky. So how do we know what's moving and what's not moving? Well, one of the ways is to take a picture. All right, here's a picture taken by one of my buddies from the San Jose club. And what he did, he just let his camera run for 4 hours of 30-second exposures. So you can see right in, oops, come back here. Come back. All right. Come back. My thing's more sensitive than I was hoping. All right, so right here in the middle, you can see it's right even not exactly in the middle. It's pretty close to the middle. That's Polaris, and that's moving around. And everything else, all the other stars are moving around it. And that's what we see. And obviously, it's a long time ago, they thought it was, all the stars and the planets were racing by the Earth. But that's not it. We realized finally that it's the Earth spinning every 24 hours that makes it hard, things move in front of us at nighttime. So it's a challenge for photographers, but there's ways to deal with it. But anyway, it's a gorgeous sight. I thought you'd enjoy that picture. All right, there's a great tool that a lot of us use, and it's called the WOT, WOT, What's Out Tonight chart. and it's done by a friend of mine. I bet a couple times, Ken Ground, and he puts it out once a month, and it's excellent. It shows basically you see, you'd stand down here with the if you're looking north, and you'd look up at all the stars, and the stars are shown by their weight, how heavy they are, how solid they are. So here's a big one. Here's a big one. Here's the Scorpion constellation. Here's Sagittarius, the teapot. Um, let's see if I can find the Big Dipper for you. Yeah, here it is. Okay. So here's Arcturus. Here's the Big Dipper. Here's the Dubhe and Merak that we talked about. And here's Polaris. So when you look up in the sky, in the north part of the sky, Polaris is usually right there and everything is moving around it. So it's pretty cool. So I'll at the end of the or soon I'll send you guys a link to this chart and also some more information about the San Jose Club because they have a lot of good things that's local and you can take advantage of that too. All right, so we found the stars here and we're going to go and add. I just pulled in this little red triangle and that's the summer triangle. And it's funny, it's not as well known as the Big Dipper, for example, but it's out all summer and you can go out any night and you'll see it. And the biggest hint is that Vega is a very, very, very bright star. It's almost at the top of the dome, if you will. It's pretty high. And then there's two other stars, Deneb and Altair, that you can see also. And it's a huge triangle, and it helps point us to stuff looking from there. One other thing about the Big Dipper, just to throw it in here, is on the handle, there's a fun place called Mizar. And the Romans, it's a double star. And so there's actually two stars together right where the handle breaks. And it's Mizar and another star. But the Romans used to call it the horse and rider. And if you could see the two stars in Mizar, then you had really good eyesight. And they gave you a bow and arrow and they sent you to the back of the lines to shoot arrows at the enemy. If you couldn't see Mizar, they gave you a club and they sent you to the front of the line to beat off all the attacking Huns and whatever. So it was always good to have good eyesight. So, take good care of your glasses. All right. All right. So what do we look at in the summer? A lot of the constellations up there, that were created by astrologers years and years and years ago. But Sagittarius is a fun one. It looks like a teapot to me, but theoretically it's modeled after a half man, half horse, I think, with a bow and arrow. Cygnus the Swan, we'll take a peek at. Cassiopeia has a W, the famous W up near the north Polaris North Star. And Hercules, the hero, is another easy one to find. And Ursa Major, the big Great Bear, we talked about as being the asterism, the Big Dipper. All right, Big Dipper and the Summer Triangle route, all the summer. What else do we look at in telescopes and things like that? The crescent moon is always fun to look at. And it's actually better to look at a half moon than a full moon because the full moon is tough to see because there's no shadows. There's no, everything's evenly lit. And then obviously, the planets like Mars, the red planet Mars, and Jupiter and Saturn are standouts. Deep space objects like the Andromeda Galaxy, M31, the Bode Galaxy, which is up in the Cigar, M81 and 2, which are up in the Big Dipper, actually. And globular clusters, which are smaller than galaxies, but there's still hundreds of thousands, groups of hundreds of thousands of stars. And there's one M13 in Hercules and a couple of others in that area. And then other burned out stars, basically, which create a gas nebula. And there's the Lagoon Nebula, the Trifid Nebula, and the Ring Nebula that you can find in the night sky as well. All right. Let me back up one. So there's a joke in here. So Susan, did your mother ever tell you your room was messy?
Yes.
How about your brother Bob? Was his
His,
messier.
yes, his was messier.
All right, so we know how to think about Messier. So there's a French guy named Charles Messier. Sorry, I had to sneak that in on you. But anyway, it's a good way to remember who he was. But he was an astronomer for the French Navy, and everybody was into comets in those days. He was in 1750, and in 1759, Halley comets came back. It's got a 75-year orbit, and he knew it was coming, and he predicted it, and he saw it, and told other people about it. And he also was discovered 13 other comets on his own, you know, viewing and discovery of the night sky. So what he did was he kept a list of fuzzy objects like galaxies and nebulas and star clusters, and he knew they weren't comets, but he wanted a list so that he could distinguish them from comets so they wouldn't get confused. And it's become a really handy list. He's got it up to 110 Messier objects now, and we just use it as shorthand for, you know, referring to the things we like to look at and are very popular and well known. So we don't always say Andromeda Galaxy, we'll just say M31. And most people that are real astronomers like you guys are going to be, will know that that's the Andromeda Galaxy, whether you like it or not. Okay, thank you, Charles. So here's some of the constellations. Here's the Cassiopeia. And like I say, it's a sort of a squished W. It's got the 5 stars here, where one of the triangles looks a little better than the other side of the triangle. So this point of the triangle points down. If you follow it down far enough, you'll find M31 in the Andromeda Galaxy. And then this star here goes back points toward Polaris. So that's the Cassiopeia. Here's Sagittarius, the archer, half horse, half man. But I think everybody recognizes it as a teapot, you know, it's strong and stout. You know, here's my handle, here's my spout. What's really cool about Sagittarius is that it's always low in the southern sky, and it looks like the Milky Way is pouring out of the spout. It's really cool. So when you're in a really dark site, not Seattle, but a really dark site, you can see the Milky Way coming up out of the Sagittarius, going through the summer triangle even, and then all the way over to Cassiopeia. So it's covers the whole night sky. In fact, yeah, I could have showed you, but if you're looking at that map of
The what's up?
the What's Up map, they have a cloudy region, a dark band going through the map, and that's the Milky Way. All right, speaking of the summer triangle, here's the 3 big stars. So Vega is at the top, and then we have Deneb and Altair. And it's up all summer, and it's just pretty easy to find, easy to see. There's stuff in it. That's fun to do. Let me show you what's in there. So one of the items is from Deneb down. We're looking at it over here. This is called the Northern Cross, or um, the Cygnus the Swan is another way of looking at this guy. So here's Deneb up here. Here's a bunch of stars that make the cross, or the T for the Northern Cross. And then way down here at the very end is the sort of the tip of the iceberg, the bird, Cygnus the Swan. And right in here, there's 2 stars. It's actually a double star. And they were too lazy to give it 2 star names, so they just call it Alberio A and B. But why it's fun to look at is because they're 2 different colored stars. Let me show you. So here's a close-up of that little region, and it's like a blue and gold, Cub Scout banquet. So one of the stars is yellow and golden, and the other star is a bright blue, cold blue star. And they've been together for hundreds of thousands of years. They are orbiting and they're gravitationally bound, but they look the same from our standpoint of time. They're always there. It's kind of fun to see something different. All right, here's another kind of night sky chart, and this is the Great Square of Pegasus. So anything you think about, like the 3 stars that are in Orion's belt in the winter, you know, anything in 3 or anything that's a square or part of a circle, it stands out because that was doesn't happen very often in the night sky. So the Great Square of Pegasus is a real square, and it has roughly four equal sides, 1, 2, 3, 4. And this star in the corner is one of the brighter stars. It's called Alpheratz. And if you have a star chart like this, it helps you get to M31 because it's a little hard to see. It's a fuzzy blob, and it's a little way. So you start with Alpheratz, and you go out 1, 2 stars. This is, again, the size of this dot represents how bright it is. So that's a fairly bright one. And this is even brighter. And then from that second one, you go up 2 more, 1, 2, and then with binoculars, you can probably see, some people see it naked eye, M31's right in this area. And it's a big object, and it's pretty spectacular. All right. Here's constellation Hercules, the hero who had all the labors of Hercules. So it's unique because it sort of looks like a part of a keystone of an arch. It's got the 4 sides, 2 are equal length, and then the top is bigger than the bottom. But over on the right-hand side, the eastern side, here's Vega, for example. It's also fairly close. Again, Vega is a big dot because it's such a bright star. So these aren't quite as bright as that, but right between these 2 edges, you'll find M13. And that's the constellation, or that's the globular cluster in Hercules called M13. So here's a photograph of it. And like I say, globular clusters are fun because they're big and they're smaller numbers of stars. They're not the billions of stars that are in a galaxy, like Carl Sagan says. But globular clusters have hundreds of thousands of stars, and they're spectacular to see in binoculars or a telescope. So that when you're looking on M13, this is what you'll see. Back to the moon. Okay, so you can buy all these charts of the moon. They'll show you where the Apollo landing sites were, and you can look at them in a telescope. You won't be able to see anything on the ground from where the NASA stuff landed, but at least you know roughly what plane or what mare they were in. But that's a full moon, and like I say, you can see Tycho. Let me use my pointer here. Here's Tycho, one of the brighter impact craters. It's down at the bottom. But we like to look at the moon best when it's in a phase. Phases of the moon changes all month, all 30 days. And where it changes from the black unlit side to the light lit side, I call that boundary the terminator. And you guys are all old enough to remember that our favorite governor, Dr. Arnold Schwarzenegger, was the Terminator in all the Hollywood movies. So that helps you remember what they call that thing too. But it's nice because it's a long shadows, and you can really see if you walk, go up and down on the craters, you'll really see it's really a 3D kind of experience. It's awesome. All right, let's go on to the gas giants. So number 5 from the sun is Jupiter. And Jupiter's obviously, been there forever. And just a quick word about the planets. The early astronomers realized that the planets were different. They knew about Jupiter and Saturn and Mars and most of the big ones that you could see with your naked eye, or what the skies must have been like, 400 years ago. But what they knew about Jupiter and the planets was that they moved separately from the planets. So we talked about all the planets, all the background stars moving around Polaris, the North Star, and they all move together and they're pretty predictable. What happens with the planets is they're in a different section of the sky as it moves around the sun. So they knew they were special, and they knew they weren't stars, but they enjoyed looking at them. And then in 1610, 415 years ago, Galileo built his first telescope, and he used it and to look at Jupiter and see what he could see. The other thing is unusual to think about Jupiter is it's very fast rotating. So that sunspot actually moves. If you're watching it for 3 or 4 hours, you can see it move in the night sky from one side of the planet to the other. And because the whole thing is going to spin in roughly 10 hours, where our planet takes 24 hours. So that's really quick for such a big, massive object. Okay. So here's a great diagram from Galileo's notes. And it looks like something my 6-year-old would do, but it worked. It's great. So it's in Italian, and people tell me this is the observations in January of 1610. And here's the dates, and Monday, Tuesday, Wednesday, Thursday, whatever it was. And what he noticed was the brighter thing was in, easy to find. That was Jupiter. And then there was a couple stars next to it. And then he looked a little longer the next day and the next day after that, and there was only 2 or 3 stars. And the stars seemed to keep moving around the main star. And eventually he watched it all month long and realized that, well, these probably weren't stars. They probably were moons of Jupiter. And he was right. So these are the 3 or 4 moons. Here's one of the 4 moons that he could see finally of Jupiter. And they've been around ever since, and we get to watch them. So the question comes up is, well, why didn't he have observations on the 1st and the 7th and the 9th? And anybody got any ideas on that? His daughter wrote a book called Galileo's Daughter, Maria, and she explained that it was raining in Rome or in Italy those nights, and so it was just like Seattle for us. We can relate to that. Okay, so here's the picture of the gallery of the planet Jupiter and its Galilean moons. So you have Io, Europa, Ganymede, and Callisto. So again, we come back to something that the kids are easier to remember all those names, and we suggest the 4th grade boys love this phrase: "I eat green caterpillars." So the 4th grade boys love it. The girls might come up with something a little different, but there it is. And it represents the Io, Europa, Ganymede, and Callisto. And it's from the inside orbit to the outside orbit. And so now you know the 4 big moons. Now, by now, they have such good telescopes and they can see so far and such small things. I think there's probably at least 90 or 100 orbiting objects around Jupiter, but they don't call them moons, and we don't have to remember their names, thank heavens. All right. Next up is Saturn, number 6, and it's named after a Roman god of agriculture. This is Saturn. So you probably all remember the Beyonce song "Put a Ring on It." Well, they did, and this is I think this is actually a Hubble picture of Saturn, but you can sort of see that the rings are huge, almost just twice the size of the size of the Saturn itself. And back in 1650, is that true? Nope, 1675. Sorry, Cassini saw the rings and he saw this gap. So he had a good enough telescope to see this division between the inner rings and the outer rings. There's another one, a tiny one right there. But this big ring in here that you can see in the telescope is called the Cassini division. It was named after Mr. Cassini. And Saturn's the second fastest spinning object in the universe, and it spins in 10.5 hours. So Jupiter was 10, and Saturn's a little slower at 10.5. All right. But it's fun to see. Actually, right now it's a little tougher for us to see because it's the angle that's towards Earth is not quite as steep. When it's a flat angle, you can really see the disk very easily. In fact, Galileo saw Saturn, and he thought it was maybe 3 planets, 2 very close to the bigger one with ears or something like that. So he was able to see something out there, but it wasn't until better telescopes realized it was a ring around Saturn. I was going somewhere else with that, but we'll keep going. All right, let's talk about galaxies. So, like I said, galaxies. Carl Sagan told us had billions and billions of stars, and they really are big. They're very large in area. So when you're looking at a telescope, just eyeball sight enhanced, you might see something sort of in this fuzzy ball, fuzzy, object range. If you take it and attach a camera to it and use a long exposure, you get a much brighter image with the core and satellites, a lot of stars in the galaxy itself. And there's even another nearby galaxy right here, and there's one right there. There are galaxies. So let me show you a picture of that. So this is one of the brighter objects in the Messier catalog. It's the M31, and it's our nearest galaxy. It's only, let me have my water. Excuse me for a second. Okay, come back here. Boom, boom, boom. All right. It's funny that I use a wired mouse for this because I thought the wireless ones were sometimes a little flaky and they'd jump ahead, but something else every now and then let's make it pop. And I don't know what that is, but Kyle and I'll have to work that out. Anyways, it's the nearest major galaxy. It's 2.5 million light years away, so it's fairly close in astronomical terms. And it's 6 times as wide as the full moon, so it's a large object, and it's great to take pictures of. This is a guy Ray Ellislick, who's in the San Jose Astronomy Club, and they have a great photography group. So if Kyle's interested in getting his camera out and learning a little bit more, he should talk to those guys because they work hard. I give them credit. Susan and I talked about, do I want to get into photography? I said, no way. I can't take anything half as good as the Hubble telescope, and these guys work their butt off to get collect all of the photons they possibly can onto an image. And then the processing is not trivial either. They have to do an awful lot of work. So I give them a lot of credit. It's a part of their hobby that they really enjoy. And I'm just happy to look through a telescope and use my green laser or my green pointer to show where things are. So it's great. This is we're getting close to the end here, and this is a picture of the comet Lovejoy that was taken by a friend of mine, Rogelio Bernard Andreo, and he's a fabulous nice sky photographer. He's published books of his photographs and stuff like that. And you can see up in here, here's what the size of the full moon would look like in the same picture. So you can see how big the tail of the comet is. And there's actually a couple of different tails, depending on whether it's hit by the sun or just, caused by the object moving through space. But this week, just another thing that's going on astronomy-wise is the Golden State Star Party. It's 4 days and nights of people, astronomers. They have 400 astronomers camping in a farmer's field up in near Alturas, the northeast corner of the state. And Susan and I used to go there a lot. And Rogelio was in the next tent next to us, so we got to know him and his family a little bit better. But it's the 4 days and nights it's a very, very dark spot, being so far from civilization. It's really a really great place, and a lot of big telescopes show up there. They're bringing everything from an 18-inch to a 24 to a 30-inch telescope, one of these Dobsonians that sits on the ground and looks at the night sky, and it's just fun to see, look through other people's gear to see what they're doing. So that, I think, is the official slideshow. Oh yeah, let me tell you a little bit about the San Jose Star Party, the San Jose Astronomical Association. Like I say, it's the San Jose Club, Astronomy Club. It was up to almost 500 people when I was strongly involved. I was VP, and before poor president got ill, so I had to take over for him for a year or two in 2018, I think it was. And then we had the pandemic, and so they lost some activity because we didn't have as much stuff going on. But back to almost full strength now, and they have a whole bunch of star parties and activities that you're more than welcome to. You just show up and You can just tell them Bill O'Neill sent you, sent you to go visit. Because so the first one coming up that I noticed was they actually Wolf Witt, friend of mine, took over the solar program that Susan and I used to run. And there's a solar Sunday once a month, and they got a whole bunch of solar telescopes. I think they're up to like 4 or 5, maybe even 6 hydrogen alpha telescopes and a whole bunch of mylar telescopes. So you can look at the sun safely at Hoagie Park, which is in South San Jose off of Bascom. And like I said, I'll send you stuff on the a map how to get there and where it is and stuff like that. They have an in-town star party on July 18th, which is at the Hoagie Park. It's also and they have a little lecture before it starts, Astronomy 101. Then they have a star party after the lecture. So you might check that out. And then Saturday, 7/19, after the Friday, there's a place, an event called Starry Nights, and they also have a binocular star party in that same area. But Starry Nights is fabulous. It's put on as it's a park. It's called Rancho Cañada del Oro. You might know of it. It's in South San Jose, almost down by what is it, Meridian there?
Yeah, I don't remember.
Yeah. It's been a while since we've been there, but anyway, it's not that far from San Jose. I think it's maybe 30 minutes, 20, 30 minutes, but it's a very dark sky because they have a big mountain so between us and the city of San Jose. So you can actually see the Milky Way in the summertime. So get down there in August and you'll be sure to see the Milky Way. So that's a local star party in your area, our star club. And there's a lot going on. It takes a lot of people to keep it working, but they're doing great. All right. So I hope you've all been writing furiously into the chat box. And if you have any questions, we can toss them out now. So Kyle, can you look at see if there's anything in there or
I actually just looked before you even asked that, and there aren't any questions that were written down ahead of time. However, I
they're
do
so
have a
shy?
question.
These guys, come on, Jeff, you must have a question.
I have a question though.
Fire away.
So when you said that on your previous slide that on once a month on Sundays you can do like you can see the sun, right? Like with filters and telescopes and whatnot.
Yep.
Do they give you the opportunity to take pictures of the sun with those filters off of those telescopes, or is it just only a viewing session?
Yeah, unfortunately, it's very popular, you can imagine. And what you get is you get a queue of maybe 10 a dozen people waiting to look into the eyepiece. So it's pretty hard to break it up and have a photographer put his lens up to it and couple it up and hold it steady. And the other problem that you have is the telescopes these days are built to track whatever they're looking at. So the sun is moving across the night sky or the day sky, and it's moving. So and it's a tiny little object. You'll know if you go down to an eclipse, a total solar eclipse. It's only about a half a degree in size,
Yeah.
and it's about the same size as the moon, which is a half a degree. And so when they go in front of each other, or more specifically, the moon goes in front of the sun, it covers it almost 100% most of the time, some of the time, not all the time, but most of the time. But anyway, it's moving, and so you have to have a telescope that has built-in tracking capabilities, which they mostly do nowadays. And so they can move it so you don't have to adjust it for every third person in line to put it back into the center of the eyepiece. So but when you go to some of the star parties that are at night, especially later at night, they might have some time where you can talk to somebody about taking a picture through their telescope. But generally on public stuff, it's a little harder to do because the public, we want to keep them interested too, and not have to wait forever for somebody to finish using the telescope.
Got it. A comment was written out in the chat box by John saying, "Great presentation, learned a lot and laced with fun facts."
There you go. Thanks. Thank you, thank you. Like I said, we enjoy it. We'll get. I run a star party up here in Shoreline, weather permitting, and we'll get 50 or 60 people and maybe 10 or 12 telescopes. And so it's fun to have people come out, the public, and see what we're doing. And we do it once a month, weather permitting, which isn't always the case. And the club actually bought some property down in the near the was it the Colorado River? Columbia River, the Columbia River Gorge, which unfortunately is about 4.5 hours from here drive, but it is so dark down there. You come out of your cabin or your tent and it is pitch black. I mean, you have a hard time picking out the Big Dipper because there's just so many stars. It's just amazing. And so when you set your telescope up there, you get to see a lot more distant objects and fun things to see.
Terry has a question.
Bill, maybe you mentioned this, but how many stars are there?
Billions and billions. Well, I mean that's the problem. The good news is I have a list of the named stars that we like to look at and we use it because we're trying to tell the telescope, okay, here's Arcturus, here's Vega, and if we tell it exactly where they are and we point the telescope, then the computer inside the telescope says, okay, now I know where I am, and I can go find Jupiter for you if you tell it the day, date, and time and stuff like that.
And the other thing, recently or within the past couple of years, and I don't remember the exact details, but professionals, whatever, set up a telescope looking at a very dark spot. There was nothing in that spot. And they ran the camera for hours and hours and hours. And it showed up billions and billions of galaxies, not just stars, but galaxies that are way, 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 way out there. So we have absolutely no idea how it just billions and, multi-billions and billions and billions of stars and galaxies. And we're still learning. That's why all of our grandkids need to become astrophysicists because we got to learn all this stuff.
You should see their rooms. I was going to use a picture of their rooms, but the room when they stay with us has planets all over the walls and stars on the ceiling. So they don't have a prayer. I mean, they're going to be in trouble from day one.
Any other questions or thoughts?
I'm glad to see you all.
Yeah.
Thanks for coming. That was great.
We want to thank you so much. It was a great presentation, and we're going to give all Gen to Gen people an examination.
Yeah, that'd be a quiz. That's right.
What is the M13? Come on, quick. Bill and Susan, thank you so much. It was just a really interesting presentation, and hopefully we'll remember some of it. So
Yeah.
Thank you all, and have a great weekend. Take care.
Thanks.
you.
Kyle, thanks for your help.
You're
Bye,
very
everyone.
welcome.
That was
Good to
was
see y'all.
great. And
Take care,
I
Jeff.
have
Thank
Ann
you.
has a question.
Oh, go ahead, Ann.
it was just another comment that I'm really good at finding the Big Dipper and Little Dipper. And now I'm going to focus on the triangle. That's a specific thing that I can do. And I love that. There's so many ways of remembering some of the stuff that you talked about. That was really great. And I love the couple interact back and forth. You must have
We're a
really
team.
worked hard on
We're a
that.
good team. Like I said,
So I have a question.
sure.
It's also interesting that all the stars are moving away from Earth,
Mhm.
and so
Wow.
the universe is expanding.
That's true. Yeah, that's the gotcha. Nobody knows why. No, I mean, Edwin Hubble, the astronomer, realized that the Earth was expanding, and they calculated, what the rate would be and all this good stuff based on mass and stuff that was going on. But it doesn't explain how fast it's expanding. They're finding out now that it's expanding much faster, quote unquote. I mean, it's not quick, but it's faster than they expected. And they really think there's something called dark matter or dark energy that's influencing the path that the galaxies take. the Earth, our universe, we think is about 13.8 billion years old. And so when you look at a star that's been far away, you're looking at light that's been traveling, perhaps a billion years. And so you're looking back in time. And so it's kind of an interesting, process of what you're really looking at through the telescopes these days, especially with the James Webb and all the other fancy tools we have nowadays. It's really great. Okay, well, again, thanks for your time. Susan's running me out to Bye Bye Birdie
Yeah, we're
today.
gonna go see Bye Bye Birdie
Yeah.
in Seattle afternoon.
Have fun.
Okay, take
Thank
care,
you.
you all.
Care.
Thank
Bye.
you all.
Thanks,
Thank
Kyle.
you.